Laurel here, Javier, Hailey, okay. 14, Christopher Dollars, Jaylee, Mackenzie, Ben Crossover, Abdul Hamid, okay, Elizabeth here, Jonathan Peters, not here, Kipling, Leap, okay, Joe, not here, Odelia, Alondra,
Here.
Matu, Vic,
Here.
Tyler not here, Elijah Smith, Jesse not here, Sullivan, Maria,
Here.
Thomas, Sriya, Cameron Waller, Walker. Okay. Okay, so now we continue to review the exam 2. So I will review today. Today I want to talk about the combination and perturbation and continuous random variables and decrease and continuous random variable. After that, we will talk about the normal probability distribution. Chapter 6, I will not talk again. I will not because it's very recently, so I will just solve the problem, solve the exam problem, something like this. Okay. Okay. So any questions so far about the exams, something like this? No question? Okay. So now we will continue the lecture. Okay. So the first today I will give you the things about the factorials. Review the factorials. Okay. Factorial. So the factorial, the formula is okay, n something like this. Okay, and factorials will be equal to 1 times 2 times 3 apply up to n. Okay, for example, we have 6 factorials, so should be 1 times 2 times 3 times 4 times 5 and 6, something like this. Okay, that's the factorials, and you will get the result. And we have two things about this chapter. So this is called combination and permutation. Combination and permutation. So what are the difference between them? For example, I want choose R object. I want to choose R object from n object, something like this. I want to choose R object from n object, and we have two cases. When the order is not important. When the order is not important, so we will the way to choose R object from n object is R n C R. That means the combination. We will use combination. The way to do that, the way to choose R object from n object is calculated by this formula, by combination. Okay. What about NCR here? Okay. Okay, NCR here is calculated by this formula. N factorial over R factorial times to n minus R factorial. Okay. That's either the formula for combination. When the order is important, we will use the permutation. So this formula should be NPR ways to do this. And the formula for NPR should be calculated by n factorial over n minus r factorials. Okay. That's all the things about this. When we choose our object from n object, for example, choose 3 marbles from 10 marbles from the box, something like this. And in this case, the order is not important, right? The order is not important. So we will use combination. Okay, we will use combination. And it depends on the case. It depends on the case. So you will look at the question and see that case is the order is important or not important. And after that, you will decide which one we should use, combination or permutation. Okay. So now I will give you some example for this. Okay. So we'll look at the sample exam. Okay. Okay. Look at the question. Okay. 13. A coordinator will select 5 songs from a list of 7 songs to compose an event musical entertainment lineup. How many different lineups are possible? Okay. So could you tell me in this case, the order is important or not important? Let me write down. So could you tell me in this case, the order is important or not? Look at the question here. So we have here, we choose 5 songs from list of 7 songs to compose an event musical entertainment listing. Okay, Robert, please.
The order doesn't matter?
Okay. Really? Any other question? Any other answer? So we look at the question here. We choose a song, right? You choose a song, right? Choose 5 songs from a list, and will be an event musical entertainment lineup. Okay. So in this case, the order will be important, right? Okay. Okay. So because the order is important, so in this case, which one you use? Combination or permutation? Okay, Robin again.
Permutation.
Okay, exactly. Permutation. Okay. Okay. So now the way to choose that. Okay. In question 13, we want to choose 5 songs from 7 songs, right? And the order is important. So now the answer should be permutation, right? And n here, n in this case is 7, and r here is 5, right? Because we want to choose 5 songs from 7 songs, right? And the answer should be 7p5. Wait, okay. Choose. And we need to calculate which one. Okay, 7p5. Okay, so 7p5 should be 7 factorial over 7 minus 5 factorials, right? And should be 7 factorial over 2 factorial. Okay. So now we will calculate this guy. And it should be 1 times 2 times 3 times 4 times 5 times 6 times 7 over 1 times 2. Okay. And here you see 1 times 2, and 1 times 2 here is will reduce because it's the same, right? So now the answer should be 3 times 4 times 5 times 6 times 7, right? And the answer, final answer is 25 and okay. Any questions so far about this? Okay. So now when we look at the question, so you need to determine in this question the order is important or not important. So you should use the permutation or combination. Okay. Clear, right? Okay. So now look at question 14. So how many ways can Karen choose 5 pizza toppings from a menu of 14 toppings? Okay, if each topping can only be chosen once. The question is the order here is important or not important? Or Robin again?
It's not important.
Okay, it's not important, right? Exactly. So because when we choose a topping, for example, we chicken and fish, something like this. You choose chicken and fish, it's same as you choose fish and chicken. Right? So it's not different, right? Okay, so now this way, in this case, the question 14, the order is not important, right? It's not important. So now we will use combination, right? So could you tell me how many ways in this case? You want to choose 5 pizza topping from 14 toppings, right? So how many ways in this case? 14. 14. Okay, so the number of ways to choose this, because you want to choose 5 pizza from 14 toppings, right? Okay, choose 5, okay, from 14. And the order is not important. Okay, we have the information, and then we imply that the way to choose that. Okay, we have okay, so this is 14 C5 ways to do that, right? And we need to calculate this number. This number should be 14 factorial over 5 factorial times this number. So this is 14 factorial, 5 factorial times to 9 factorial. Okay, so now you can use calculator to calculate this number. If you use calculator to calculate this number, the answer should be 2002. So this means that you have 2002 ways to choose 5 toppings from a menu of 14 toppings, right? Okay. That is the difference between the combination and permutation. Okay, when you look at the question, so look at the case here and look at the question, specific question, and determine that the order is important or not. Okay, and after that you will use the formula, the suitable formula. Okay. That's it about the permutation and combination. Okay. Okay, now we will move on to the question 16. Okay. Suppose that your boss must choose 3 employees in your office to attend a conference in Jamaica, because all 27 or you want to go. He decides that the only fair way is to roll names on a hat. Okay, so that the question is, what is the probabilities that you, Rebecca, and John are chosen? Okay, this is the question, something like this. Okay, so now we have the boss want to choose 3, right? 3 employees from 27 employees. So could you tell me, in this case, the order is important or not important? Okay, you please.
It's important.
Important?
Yeah.
Why you say that?
Because you have to have Rebecca, yourself, and John.
Okay, thank you. What's your name, please?
Alondra.
Okay, Alondra. So here, so we will see that because choose 3 employees in the office to attend the conference, right? Conference. So for example, I choose ABC, go to the conference. So it is the same that I choose CBA, go to the conference.
Oh, no, it's not important.
Yeah. I will give another example. When I want to choose 3 people to election, like resident, vice resident, something like this, secretary, something like this. When I choose 3 from people, so that is the important, right? The order should be important. But in this case, I choose 3 people to go to conference, right? So the order is not important here. Okay. In this case, the order is not important. So, okay, I will put some right here. 15. Okay, because the order is not important, and I want to choose the boss want to choose 3, right? Choose 3 from 27, right? So there are 27 C3, okay, ways to do that, right? So the question here is not to ask you how many ways to choose that, right? How many ways to do that? They ask you to find the probability. Okay, in the handling homework, some of you know the answer, something like that. You know how many ways. Okay, you write the answer. You write there are something like the number of ways. But the question is not ask you the ways. They ask you probabilities. So now look at the answer. Look at the question. They ask you probability, not ask you how many ways to choose. To choose 3 people from 27 people. A question?
Would the fraction be 1/9?
Yeah, exactly. The probability should be 1 over this number. Is for your question?
Oh, no, I was trying to answer it. I asked us the answer 1/9.
1 over 9 is probability.
Yes.
Why you choose? Why you get the answer? How do you get the answer?
Oh, it said answer or fraction. Oh, I had just did that from 3 over 27 and then
Okay.
simplified it from there.
Okay. But here, so look at the question here. The probability is that this guy, you, replica, and so on are chosen, right? So easy. Okay. But the way to choose that, the possible way to choose that is this number, right? Is this number, and the probabilities should be 1 over to this number. Okay, because the totals, the ways, the total way to choose that, the number of ways to choose that is this number, right? Is this number, and you only have one possible way. That is you and Rebecca and John are chosen. So the probability should be 1 over to the total number of ways, right? Okay. So this is the probabilities. And okay, so now I will give you the answer. And this number should be 1 over this number. How to get this number? You need to calculate this number here. This number here is 27 factorial over 3 factorial minus 27 minus 3 factorial. Okay. And after that you will get this one should be 24 factorial. And now you can use calculator to calculate this number. And when you use calculator, it should be 1728. Okay. Use calculator to calculate this. A question about this. You Taylor, right? Thank you. Okay. So that's the question 14, 15, 13, 14, 15, 16. We talk about the combination and permutation. Okay. And question 15, you can use calculator to calculate this number. Okay. And the answer should be. I think I got the wrong answer here. So this should be 2925. Okay. So we check by yourself. Okay. Maybe you guess computer. Check by yourself. And the answer for 15. The answer for 15 is 1. Okay, this is just computation. You can use calculator. Okay, when you look at this problem, when you see this problem in your exam, okay, you use calculator. Okay, so that's about the combination and permutation and factorials. Okay, this is in chapter 4, and okay, you can look at my lectures about this. You can look at my lectures, video lectures about this. or you I summarize everything here. So you can look at my video today, so you can have brief reviews about this. Okay, that is all the things about chapter 4, the previous material and today. So we covered all the things about chapter 4. And now I will go to the chapter 5 review. Okay, chapter 5 we only have 5.1, right? Only have 5.1. That is discrete random variables. Okay, discrete random variable. Okay. Okay. So in this case we have the random variables. So we have to go to this. This one is random variable. Okay. The random variables is the value. The values is determined by the outcome of a probability experiment. Okay. For example, when I toss, when I roll a dice, when I roll a 6-sided die. For example, when I roll a 6-sided die. So the value should be 1, 2, 3, 4, 5, 6. Okay. So I call the values of the result when I roll a 6-sided is a random variables, right? Because it's a random, right? It will be 1, it will be 2, it will be 3, it will be 4, right? So that's the random variables. That is the example of random variables. Okay. And in this case, we will have two cases of the random variable. We have two cases. That is discrete random variable. Discrete random variable and continuous random variables. Okay. When we talk about discrete random variable, the values of this variable can be counted. We can count 1, can be count 2, 3, 4, 5, something like this. And regarding the continuous random variable, that means that we cannot count, right? We only measure it or something like this. For example, when I talk about the temperatures in Detroit, something like this. In this case, you cannot count it, right? You cannot count it. You only measure it. Okay. Okay. Because, for example, we have the 17.5 degrees, something like this. You cannot, you will not know what is the next value, right? The next value is this number or this number, something like that. We don't know, right? So in this case, the temperature is continuous random variable. But when you look at the value here, the value of the when you roll the 6-sided dice, you know 1, the next value should be 2, the next value should be 3, right? That's you can count it, right? You can count this value. So this is the discrete variable. And regarding the continuous here, the temperature you cannot count, you only measure it. You will know the temperature should be from this number to that number. Okay, you cannot count it. So this is the continuous random variable. Okay, clear, right? Okay, so please distinguish between the random variable and continuous variable. They will ask you, this case is random variable, is it continuous or discrete, something like this. Okay, so look at the question 17. Okay, question 17. So classify the following as either a discrete random variable or continuous random variable. Okay. The number of pizza delivered to a college campus each day. In this case, could you tell me this is either continuous or discrete? Maria, please.
Would it be continuous?
What is continuous? Okay, continuous. You cannot count, right? But here the number of pizza you can count is one pizza, 2 pizza, 5 pizza, something like this, right? So in this case, this is the random is the degree random variable. Okay. Regarding the random variable, we cannot count like temperatures, like the height of student, something like this, the weight of student, something like this. That's the continuous random variable. Okay, is it clear, guys? Okay, so that's about the definition about random variable. So we have two properties of random variable. Okay. Okay, so we have the property here. Random variable. So we have the first property is the probabilities of the random variable equal to some values will be from 0 to 1, right? The probability cannot be 2, cannot be equal 2, cannot be equal 3, cannot equal 4, something like this. It's only from 0 to 1, right? Okay, that's the probabilities. And the second one, the sum of all the probabilities in all cases should be 1. Okay. For example, we have the I consider the example when I roll a 6-sided dice, the value should be 1, 2, 3, 4, 5, 6, right? Okay. So what is the probability I get 1? What is the probability I get the value 1? Because we have 6 value and I want to get value 1. So could you tell me what is the probability that I get the value 1? You have 6 value, right? 1, 2, 3, 4, 5, 6. Okay, so now the question here is I want to get 1. So could you tell me the chance to get 1? The chance or the probability to get 1? Okay, dollars, right? Risk, okay, risk dollars.
1 out of 6.
Yeah, exactly. 1 over 6. And it is same with 2, right? 1 over 6, 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 right? And you can see that the sum of these all possible results should be 1, right? 1 over 6 plus 1 over 6 plus 1 over 6 equal 1, right? So this is the second probabilities, second properties here, right? So you have two properties that you need to remember. This is the first one and the second one. Okay. So now you will look at the question 18. Question 18. So they ask you to determine whether or not the distribution is the degree probability distribution. Okay. So look at the table here. So this is the value to get -3. So the probabilities to get the -3 is 1 over 8. Okay. And the probability to get value 0 is 1 over 2. And the probability to get 7 is 3 over 8. That is the meaning of this table. Okay. And that's called degree probability distribution. And you can see that. You will check two properties here. Okay, the first property is from 0 to 1, right? The probability should be from 0 to 1. So you look at here. So all the probability here from 0 to 1. Okay, so it's certified, right? Okay, that's fine. Okay, now we will check the second properties. The second property say that all the sum of all probability should be 1. So now you will look at the table here. So we will need to make the sum of these. Okay. Okay. Question 18, right? Question 18. So you need to check 1 over 8 plus 1 over 2 plus 3 over 8. Okay. And okay. So now you need to check this, and it's 1 over 8. Okay. So you need to make the same 8 here. So 4 here, 3 over 8. So 1 plus 4 plus 3, 8 over 8 equal 1. Okay. So it satisfies the second properties, right? Okay. So now this distribution is the random variables. Okay. Clear, right? Okay. Now we move on to the next examples. You will see that 19. It's in 19. So determine whether or not the distribution is degree probability distribution. you also check two properties, right? Check only two properties here. The first one, the value from 0 to 1. The second one, the sum of all the probability is 1. Okay, so now we need to check this. We need to check this. Okay. The first one is okay, right? The first one is okay because 0 it will be less than 1 over 8, less than 1 over 8 and 5 over 8. Okay, that's fine. So the first one is fine. Okay? Because it runs from 0 to 1. Okay, now we need to check the second one, the second probabilities. That is the sum of all the probabilities is 1 or not, right? So the probability is 1 over 8 plus 1 over 8 plus 5 over 8, 5 over 8. So it should be 7 over 8, right? Clear, right? A 7 over 8 is different from 1. It's not 1. Right? Not 1. So in this case, this distribution is not satisfy the second properties, right? The second property. Okay, so now we can conclude that this one is not a discrete random variable probability distribution. Okay, clear, right? Okay, this 19 you will say that this is not discrete probability distribution. Any questions so far? Okay. That's all the thing about. Okay, not all the things. Now we need to go to the expected value. Expected value. Okay, we go to question 21. You should try to solve all problems in the sample test. You should try to solve all problems in the sample test because the second exam will be very similar to the sample test. Okay, very similar. Okay, so you need to try to solve it. You understand it. Maybe in the sample, in the real test, they will change the number. Okay, just change the number. You need to try to solve all the problem here. Okay. Maybe I will not cover all the thing today, but you should try to solve all the thing here. If you forget something, you can look at the previous material and try to solve it. It is very similar to your homework. If you do homework, so I think you can easy to solve all problem here. Okay. And now we move on to the expected value. Expected value. Okay, for example, I have the table for the distribution here. For example, here xi is the probability of the random variable is equal to specific value. For example, we have xy, x2, x3, x4, xn, something like this. Okay. That's either the table for this, and the probability to x equal to x1 is b1, x equal to x2 is b2, b3, b4, and b5, bn. Okay, blah blah. And the expected value here, the expected value should be x1 times b1 plus x2 times p2 plus xn times pn. That is the formula for expected value. That's covered in chapter 5. Okay. So now we have the table for this. And the question is to find the expected value. Okay, 21. So expected value here. Okay, the expected value here should be calculated by this formula, right? Okay, so this is negative 3 times to 0.1. Okay, plus to the the value -2 times to the corresponding probability. -2 times 0.1 plus -1 times to 0.2 plus 0 times 0.3 plus 1 times to 0.3. Okay, I apply this formula. Okay, and after that I will get the result here. I will get the result here is -0.4. So the expected value say that you will get this value -0.4 when you in the future when you do the experiment a lot of time. So that's either maybe not approximately. So the expected value can help you to choose which is the better plan. Okay, for example, in the question 20, okay, look at the question 20. So you will have the plan A and plan B. Okay, the question asks you which plan has a higher payout. Okay, in this case, you will calculate the expected value of plan A and the expected value of plan B. After that, you will compare them. Okay, if the expected value of one plan is greater than that another plan, so you will choose the first one. Okay. Okay, now I will look at the question 20 and I will calculate two expected value. Okay. Okay, we will go to the question 20. So I will calculate the expected value of the plan A. Okay. So you use the same formula. Like this, so you will get the result should be this number, and expected value of B is that number, is this number, and after that you see that the expected value of B is greater than expected value of A, right? So the conclusion that we choose plan B. Okay. Question like this. Maybe in the exam where they will have the question like this. We have two plans and you need to choose one plan. Something that in this case you need to calculate the expected value of each plan, and after that you will find which is the better. Okay. That's all the things about chapter 5. Any question? Okay, I will try to go to the chapter 6. Okay, chapter 6 I will not talk about the theory. Okay, because it's covered recently. Okay, so I will not talk about the theory. Okay, I just give you some practice examples. For example, 22. Okay, for example, 22. Go to 22. So I have the x here is 30.3. The mean here is 63.9, and here is the okay. Here is the variation. Okay. Oh, I forgot something. The variation. Deviation, okay, deviation. Okay, we have mu here is the mean, and sigma here is deviation. Okay. And now they give you the picture for this. Okay, they ask you to determine what is the mean and what is the deviation, what is the value in this graph. Okay, so mean here, mean is the middle point, right? So this is the mu here is 63.9, right? Okay, And deviation, okay, deviation should be, okay, this is the distance from mu to another, is this one, okay. So you can determine which is which is the value here and which is the value here by, okay, 63.9 plus the deviation. So the deviation here is 3.7. So now you see that if you plus 3.7, so this is the next value, right? But the value here is 70.3, so it should be greater than here. So it should be stay here, right? Should be stay here. Okay. So they will give you some multiple choice for this. The question you have some multiple choice. So they will give you X here, X here, X here, something like this, X here. Okay. So we will choose which is the correct answer to determine which is the correct graph. Okay. That's the question in the exam. They will ask you like this. Okay. And now, okay. So the question calculate the standard score. Standard score. Z or Z score. Okay. Okay, Z score or standard score. So Z score should be calculated by this formula, X minus mu over sigma. Okay. And if you have X value, you can find the Z value. And if you have Z value, you can also find X value by this formula, Z sigma plus mu. This is the Z from. If you have X, we can find Z. If you have Z, you can find X. Okay. That's the Z score. And look at the question 23. Here they give you X value. They want to calculate the standard score. That means calculate the Z value. Okay, Z here is X minus mu over sigma. And X here is 29.8. Minus mu here is 25.1 over 23.3. Okay, and after that you will get the answer for this. The answer for this is 0.2017. That is to calculate the Z score. Okay. And the kind of problem like find the areas. Okay, find the area. So you need to use the table here. Okay, I need to use the table. I did a lot of exams. I did a lot of examples about find the areas or find the probabilities of the bell-shaped distribution in the previous class. Okay, so now I will give you some example for this. Some example. Okay, so you can look at the maybe I will say. Okay, problem 25. Okay, 25, they ask you find the area under standard normal curves to the left of Z is equal to 0. Okay, so this is 0 here, so it's in negative 0.22. Okay, they ask you to find the area, this one, this region. To do that, you need to look at the table here and find, okay? Look at the table here and find, okay, negative 0.2. Okay, in the first column, and look at the second. Okay, so you need to find in the table. We have the Z here, so you need to find negative 0.2. Okay, this is the first one, and you look at the row here and find 0.2. Okay. After you find it, and you make the intersection between them, right? Make the intersection between them, and the value here is the answer. The value here is the answer. So you will look at the table. So the answer should be 0.4129. So look at the table and find like this. Okay, find in the first column, find in the row, the first row, these number. Okay, and after that you will get the result here. Okay, that's the way to find the areas of the standard normal distribution. Okay, any question? Okay, that is the kind of problems about normal distribution. Okay, let me see. Okay, I will give you one more problem, and after that, you will try to solve all problem here. Okay, try to solve all problem in the sample test. Okay, because the sample test will be very similar to the real test. Real test. Okay, sorry. Try to do that. You will get the great result in the exams. Okay, so now I will go to the final one today. It's the 30. Okay, in this case they give you not the normal the standard normal distribution. They give you the normal distribution, general normal distribution. So we need to write something about this. Okay, in this case we have mean here. Mean here is 31, right? Mean here is 31. They give you the variance here. The variance here. Oh, the variance is the variance, not deviation. Okay. Some of you will get the wrong result if you say that this is the standard deviation, but it's not correct, right? This is the variance. Okay. Okay. The standard deviation will be calculated by this formula. The standard deviation will be calculated by the square root of variance. So the standard deviation should be 4, not 16. Okay, some of you will get the wrong result. If you say that the sigma here is 16. Okay. Okay. Then the question is ask you find the probability that the diameters selected is greater than 25 here. Okay, x here is 25. Okay. So the question here asks you to find the probability of x greater than x, right? Okay. So as you know, the probability of x greater than x should be approximately probability of z greater than z. And you need to change x to z by using the z standard score formula. Okay, z here is x minus mu over sigma. Okay, and x here you have is 85 minus 81 over 4. So it is 1. Okay, that is the z. So the probability, the question is ask you find the probability greater than 85. That means that you need to calculate the probability of z greater than 1. Right? Okay. So now you will draw the picture for this. Draw the picture for this. Okay. See that? Okay, 0 here is 1 here. So they ask you find the probability of z greater than 1. That means they need to calculate this area. Okay. But we cannot use the table to calculate the area from the right. So you need to calculate the area from the left, right? Okay. So you look at the table and you find the probabilities rate is greater than 1. Okay. The area of this one, of the y1 is 0.8. Let me see. It is 0.8413. And you know that the total area is 1. So you say that. So the area here, or the probability of z greater than 1 is 1 minus this area. And after that, you will get the result is 0. Okay, that's all the things about the normal distribution. But you will try to solve all the problem here. Okay, it is similar and and some advanced problems. Okay. Any question? Okay. If you have any question, you can let me know in my office hour or send me the email if you want. Okay. Thank you for your attention.
Where can we find recordings of your sessions? Where can we find it on Canvas?
Five what?
The recording sessions, where can we find it on?
You can find all the things on Canvas here. As I said you before, when you look at home here, so you see which file upload all the recording here or recording
Okay.
here. Okay.
Thank you.
We don't have classes Friday, right? So we could take the.
For what?
Wait, do we have classes Friday or no?
No, we
Okay.
not have a class on Friday.
Okay,
This is
that's
your
fine.
for exam, right?
Okay, yeah.
Not class on Friday, okay? Stay at home and do the exam. Huh? So you all get forgot about it. Okay, stay at home and do the exam. Okay. Let me know if you have any trouble. Just see here. Okay. No problem. Okay.
So we take the exam on Friday, we don't come in?
Huh?
So we take the exam, right?
At home? Yeah, at home. Exactly at home. Yeah. The same at exam one.
I'm good at.
Okay, have a good day too.